All right, we'll give everyone a couple more minutes to connect. So welcome to lesson 4 of the Mathspace Academy. I'm joined today by Jono. So Jono is going to be your teacher going forward.
You guys.
Jono is one of our senior content developers at Mathspace. So a lot of the questions that you'll be seeing today, Jono probably had a hand in writing them or writing the hints.
Yeah.
This particular topic, I think, was one that you made, right? Yeah. Awesome. So if there's any mistakes in there as well, we can blame Jono. I'm sure he'll fix them quick smart. Okay, so to play along today with all the questions we're going to be going through, just visit at joinpd.com and type in that code LDNEU. And you can see we've got a bunch of attendees that haven't joined the class yet. So we're going to give you 2 more minutes to join this class, which is going to be focused on inequalities today. So hopefully everyone's done a bit of inequalities in their class. I think even if you haven't done any, you'll be able to learn it really quickly today. And we'll just be going through a bunch of problems, worked examples and things like that. And then just testing how much you know. So hopefully everyone will just ace it all. If you followed our equations lesson from last week, inequalities is pretty much the same with just a few little extra things that you got to remember.
We've got 6 in now.
All right, we're going to get started, even though we have 13 in the class. So I think a few more might join as we go. But just that code will stay up in the top right of screen. So for those who are just having a bit of trouble connecting, you can get in there. All right, great. So I will pass over to you, Jono, to begin the lesson.
Hey guys. Oh, that didn't change. That should say inequations. I totally changed that. That's okay. Just imagine it says inequalities. So today we'll be looking at solving linear inequalities and also graphing linear inequalities on a number line. Most of you probably looked at inequalities in year 7 very briefly, and then probably not for the last 2 years. So some of this will just be a recap, and we'll quickly move on to looking at the differences between these and solving equations. So it's just a couple of things you need to be aware of. Okay, just quick housekeeping. This is covering the year 10 curriculum, not the advanced curriculum, but in this topic it's the same anyway. Won't be able to cover everything. Let me know if you think we need to go over some easier stuff or some harder stuff. Got something in the chat. What's that? Class will be recorded and available at mathspace.co/au/academy. The chat is on. Please use it sensibly, otherwise we'll have to turn it off. Don't want to have to do that. And use the Q&A to ask questions. We have a challenge question at the end we'll get to, and before that we'll have a quick question and answer session. Okay, yeah, as usual, we have the YouTube videos that go along with what we're learning today. Feel free to check them out. I thought I put a link there. Okay, let's just start with some really quick, simple equations, 2 or 3 step equations, just to get us warmed up. So have a go now at this, write your responses. Got a few answers coming in. Remember guys, if you're doing this on paper, you wouldn't just be writing a number as the answer. You would actually want to write x equals whatever you think the answer is. Writing numbers is not the best. Just wait for another 30 seconds to get a few more responses in. A couple of you showing working along the way, which is good. Nice and simple. Okay. Let's show some responses. Yeah, so looks like one person showed their first step. They've taken away x from both sides, keeping it balanced, and then divided by 3 to get x equals 5. Yeah, so that was a nice simple one. Don't really need to launch that one and show you. I think we all know how to do it. Okay, now just simple multiple choice. Insert the correct inequality sign between these 2 numbers to make the statement true. Yeah, we've got some responses coming in. go another 30 seconds. Okay, most of you are picking the correct answer. One person went for the greater than. I saw one other person quickly changed their answer as well. All right, so in this case, draw on this screen. Let's just quickly launch this one. So we have two symbols. This one, which is less than, and obviously the other one is greater than. There's the old way of remembering it, which probably was used in year 7. We don't really need to think about it now. Just imagine an alligator or some sort of other monster. It wants to eat the larger number. So in this case, we'll put in a less than symbol. -7 is less than 7. And we'll submit. Oops, of course, I need to actually put it in, not write it in the box. And there we go. So there, what you've learned in year 7, less than and greater than. We'll also be learning about less than or equal to and greater than or equal to, which I don't think was touched on in year 7 at all. So here, write a sentence that describes this in words. I don't read it out because then I would be describing it in words. Okay, just another 10 seconds. Still 5 of you haven't responded. And I'll just show the correct ones. A is greater than or equal to 58. A is greater or equal to 58. Similar. Few of you had the other way around. 58 is greater than or equal to A. One person had A is less than or equal to 58. Now, obviously this, you can see that symbol. It sort of just looks like the greater than symbol with an extra line. So this is basically the greater than symbol with an equal symbol as well. Now, in some of the later ones, when I'll be asking you to write something like this. Your keyboards don't have a symbol for greater than or equal to or less than or equal to, so feel free to just write the greater than symbol and then the equal symbol next to it. There is a symbol for it. If you go into your character map, if you know what you're doing, you can copy and paste it out. But feel free to just write the greater than symbol and the equal symbol. Okay, that's most of you responded. Most of you got that right. That's good. So let's just go to the next one. Here we have the symbols. Greater than or more than, greater than or equal to. You can also think of this as at least. If x is at least 10, that's the same as saying x is greater than or equal to 10, or not less than 10. Same for here, less than or equal to. If 3 is less than or equal to x, then 3 cannot be more than x. It can equal x, it can be less than x, it cannot be more than x. So on worded questions especially, you won't always see greater than. You might see no more than. You might, in a probability question, have something like, what is the probability of rolling a number that is no more than 5, which would be greater than, sorry, less than or equal to 5. Okay, next one. Unlike in linear equations, when we solve it, we only have one solution. Whenever we're solving an inequality, there is generally an infinite number of solutions. So here's one. If x is greater than 9, what is the smallest integer value x can have? Now remember, integers, oh, is this the right? Shouldn't enter a number, yep. So remember, an integer has to be a whole number. So what is the smallest whole number x can have if x is greater than 9? We've got 3 responses so far, all correct. We'll just give a little bit more time here. 4 responses in. I think everyone's going to get this right. Oh, one person not. So someone had an answer of 5. They've changed it now. Obviously, if x was 5, we would have, let me just open this here. If I replaced x with 5, I would have this. 5 is greater than 9. Now, 5 isn't greater than 9, so it can't be 5. What's the smallest number that is greater than 9? It's going to be 10. If the question just said, what is the smallest value x can have, then x is greater than 9. There is not really an answer for that, because anything greater than 9 would be an answer. So 9.01, 9.001, 9.000000007, etc. So there is an infinite number of answers if it just simply said, what is the smallest value x can have? Let's go back to there. Moving on. Okay. Now, this one, only one of these answers is correct. There are many, or an infinite number of answers. Only one of these ones is correct. So which of the following is a possible solution to the inequality x plus 7 is greater than 12? A few people chopping and changing their minds here, it looks like. Remember, we can always test a solution. So if I picked 4, I could replace x with 4. Let me just quickly show you here. So if I thought 4 was the solution, let's, instead of having x, let's write 4. 4 plus 7, oh, that's a great 7, is less than 12. 4 plus 7 equals 11. So now we have this statement, 11 is greater than 12. So we know 4 can't be a correct answer. Minus 20, it's obviously not that. Okay, let's just show some responses now. 4 of you chose the correct answer of 6. 3 of you, I think, falling back into your equation days, chose x equals 5. Now, if I had 5, we'll end up with 5 plus 7 is greater than 12, which is saying that 12 is greater than itself. That's what I mean. If this was an equation, x plus 7 equals 12, then yes, x equals 5 would be the correct answer for this. But it needs to be greater than 12, so we need the only choice here that is greater than 5, which is 6. So if that was x equals 20, that would also be a solution. So it's important to remember it's not quite the same as solving equations. The actual answer to the equation isn't necessarily correct. If this was greater than or equals to 12, x equals 5 would be the correct solution. Okay, next one. So now we're just solving what looks like one of the linear equations we're used to, except now we've got to worry about this symbol here. So 5 is less than or equal to x minus 7. Whoops, didn't mean to show that yet. So one way of doing these questions is just to replace the symbol with an equals sign and just remember to put it back at the end. So if we have 5 equals x minus 7, I can add 7 to both sides. And that gives us 12 equals x. And now I'm at the end, I can just put back in this symbol. Or we can write it the other way around, like the letter on the left-hand side. When you do that, just remember to change the sign. Obviously, if 12 is less than or equal to x, x has to be greater than or equal to 12. And we can put that in. If you're using Mathspace, you can just do the greater than symbol and then hit the equals, and that will come up as your answer. X equals 12. There we go. Looks like most of you got that right. We'll just quickly show a few. Yeah, x equals 12 This would be correct if the question asked what is the smallest integer value. As it is, it's not quite correct. This is saying x equals 12 is the only answer. Obviously, if x equals 13, it's still correct as well. So this is the correct way. X is greater than or equal to 12. I'm rethinking their option there. Okay, so x equals 12 is a solution. It is not all of the solutions. So in inequalities, we want to write a statement that shows us all of the solutions. So much like here, we want to write x is greater than or equal to 12. If x was 20, we can just quickly check. 5 is 5 less than or equal to 20 minus 7, which is saying 5 is less than or equal to 13, and 5 is always less than or equal to 13. So we know that any value of x greater than 12 or equal to 12 will be a correct solution for this one. Okay, we can move to the next one now. So this is a slightly trickier one now. This is where the difference between inequalities and equations becomes obvious. This is the one trick you really need to be aware of. So I'll give a bit of extra time for this one. Remember, once you've got your answer, substitute it back in and just check if that's true. Like if I have 2 here, x is 2, I'd have 7 times 2 is 14. And that's not less than minus 35. So I know x equals 2 can't be in my solution path, in my range of solutions. I'll give you a minute or so to go over this one. If you get this wrong, don't worry, you haven't actually learned the trick here. Okay, 3 responses. I think there's one person here that still hasn't joined the Pear Deck, so if you want to go to joinpd.com, LDNEU is the code, and you can play along at home. Or at school, if you happen to be at school. Okay, it doesn't look like anyone has the correct solution yet. Actually, no, this doesn't even have the trick. What am I talking about? I've tricked myself here. You all have the correct solution so far. Okay, 6 of 10. Let's just open it up now. If you said x is less than or equal to minus 5, you are correct. This is the not trick one. The trick one is coming up soon. Let's just have a look. To solve an inequality for x, we want to find the range of values of x that satisfy the inequality. We have 7 times x is minus 35. So obviously, if I divide both sides by 7, keeping the symbol the same, we're on the right path. So minus 35 divided by 7 is minus 5. And obviously, this just becomes x. And we get x is less than or equal to minus 5 as our solution, which most of you had, which is good. Yep, x is less than or equal to minus 5. Remember, if this was a test, writing minus 5 by itself, you wouldn't get any marks for this, depending on how strict your teacher was. If you might get half a mark, but this could be x is greater than minus 5. It could be x is less than minus 5. It could be x is greater than or equal to minus 5 without actually providing the context. Just writing a number, you're not actually answering the question. Your teacher will know that you obviously understand what you're doing. You just don't know how to correctly write your answer. So here, this one here, x less than minus 5 is all of the solutions but the x equals minus 5 solution. So that's why we need to use the equals sign here. All right, let's go to the next one, which won't have the trick yet, but it's just some bigger numbers. So we have 10x minus 90 is greater than or equal to 70. Feel free to include the steps of working in your solution if you'd like. Remember, in a test, always show your steps. If you get the first line right, and then you make a mistake later, you'll still get marks if your first line is right. Whereas if you have the wrong answer only, you'll get nothing. Yeah, looks like we've got 2 correct answers so far. We'll give maybe another minute. This is a slightly harder one. Yeah, it looks like most of you have it. Good, this one's showing the work. I won't need to do it now. So our first step, we have 10x is greater than or equal to 70 plus 90. So we've added 90 to both sides, which equals 160. So now I know 10 times x is greater than or equal to 160. Dividing both sides by 10, I get my final answer. X is greater than or equal to 16. Now we can test it. It's always worth testing. If, let's say 20 is greater than 16. If I have 20, I would have 10 times 20, which is 200. Take away 90 is 110, and that's definitely greater than or equal to 70. So we have it right. That's one of the beauties of equations and inequalities, is once you've done your working and you have your final answer, you can always test it and actually see if it's correct. Next one. All right, trickier now. This has got the trick, so I'll be very interested to see if we do this one correctly. So minus 3 times the sum of x plus 9 is greater than or equal to minus 6. So you could either expand the brackets out here, or you might notice that minus 3 and minus 6 have a common factor. So we could go straight to x plus 9, perhaps, on our left-hand side. Now, this is where it's really important. I said earlier, you can just replace this symbol with the equal sign and do all your working and put it back at the end. This is where probably best not to use that approach unless you know what you're doing and you get it, you do the right trick at the end. Okay, looks like one person has had it wrong, tested their solution, realized it was wrong, and then made exactly the right change to get the correct answer. I believe that was Verinda. So well done, Verinda. Yeah, we'll just go another 30 seconds. Okay, that's probably enough. All right, so many of you had x is greater than or equal to minus 7. Looks like a few of you are now rethinking this. All right, so let's test this. A number that's greater than minus 7 is 0. 0 is greater than minus 7, so let's test that. If I replace x with 0, I'll get 0 plus 9 is greater than or equal to minus 6. Now, I'll divide both sides by minus 3, and I'll get 0. Oh, actually, do I want to do that? Oops, sorry, I'll put minus 3. Let's evaluate that. 9 minus 3 times 9 is greater than or equal to minus 6. Minus 3 times minus 9, sorry, minus 3 times 9 is minus 27. So I end up with this final answer. Minus 27 is greater than or equal to 6. It's clearly not. So what's going on here? Now, let's just take a really simple example. 3 is less than 5. Now, if I multiply this by minus 1 and make it minus 3, and I do the same thing to the other side, I've now got this statement here. Minus 3 is less than minus 5. Minus 3 isn't less than minus 5. That's wrong. So what we do, let me just clear this. Let's start with 3. Erase. If I have 3 is less than 5, when we times both sides by -1, oops, I don't need that. What we have to do is actually switch the sign. If 3 is less than 5, -3 is obviously greater than -5. So we can do the same thing here. Let's just copy that out. What I want to do here is I want to divide both sides by -3. So if I divide that by -3, I'm wrong. So I need to actually change the direction of my signs. Now I'm correct. Can evaluate that. -6 divided by -3 is just 2. So now I'm left just with this nice simple thing. X plus 9 is less than or equal to 2. Subtracting 9 from both sides. And I have x is less than or equal to -7. So looks like a few of you realized and changed your answer to x is less than or equal to -7, which is great. This is why it's good to always test. Once you've got an answer, stick it back into the actual question and see if it works. So now let's just quickly test again. Something that's less than -7 is -10. So if I have -3, we'll replace x with -10 plus 9 is greater than or equal to -6. So this is just saying -3 times -10 plus 9 is 1 is greater than or equal to -6, which it is. This is just -3, and that's obviously greater than -6. So we know that is our correct answer. Okay, is that the same one? No, that is a different one. So this is just a slightly harder one. Although in this case, I don't think we'll be dividing by a negative. So whenever you divide or times both sides by a negative number, we need to switch the signs. There's a few steps involved here, so I'll give another minute or so to get through it. So I just realized there's some things in the chat that was vanished from me before. So Vincent wasn't able to join the pair deck, it looks like. Yeah. X is greater than or equal to 1, Vincent's saying. Let's just test 2. I get 4 minus 1, 3 times 1. Okay, let's actually take a different approach to this one. Let's just think about it logically. 3 times something has to be greater than or equal to -3. Now I know that 3 times -1 is greater than or equal to 3. It's in fact equal to 3 minus 3. So I know that this 2x minus 3 has to be greater than or equal to -1. All we're doing there is dividing both sides by 3. Well, square brackets, where did they come from? Yeah, so that's correct. Now all we have to do, add the 3 to both sides. We get 2, divide by 2, and we get the answer that Vincent came up with. X is greater than or equal to 1. That's X greater than or equal to 1. Great. One person had their sign the wrong way around. That's okay. So in this case, the negative was already on this side always. We divided it by a positive number, so the sign didn't change at all. I could have divided both sides by -3. Let's just see what happens if we did that. Yeah. So if I actually divided by -3, it'd be a weird thing to do, but the 3 would become a -1, and I would be left with this 2x minus 3. We switch the sign in this case, and that's going to become 1. But then we've got a negative -2x. We'd need to switch it again, so we won't do it that way. All right, let's just quickly look at the second part. Which of the following values of x satisfies the inequality? So x has to be greater than or equal to 1. So I know x equals 1 is a possibility, and x equals 5 is a possibility. Anything less than 1 won't get the correct solution. Okay, next one. Oh, I just did that for you. You should find this really easy. You can only choose one answer though, unfortunately. I couldn't work out how to allow multiple choices here. So just choose one of the correct answers. X equals 1, x equals 5. Looks like some people are just switching between the two. So let's just go to the next question. Now, this is much harder. We have variables on both sides. There are negatives going on. So be really careful now with your signs. We obviously want to take all of the numbers to one side and all of the terms with x to the other side. Which way you go is entirely up to you. You'll get to the right answer whichever way you go if you do the steps correctly. My usual approach would be decide which side has the least number of x's and go to the side with more. So -3x is more than -5x. So I would be getting rid of the x's from this side first and getting them over to this side. You could go the other way, but then you'd just have to do an extra step. Okay, let's just, bunch of different answers coming up here. One of the answers, x less than 5. If x is less than 5, let's pick 0. So if this is 0, that goes. This bit goes, that bit goes, and I'm left with -7 is greater than 3. So x equals 0 can't be a solution to this inequality. What happens if x is 5? If x was 5, well, this would equal, let me quickly go here so I can draw on the screen. If x was 5, we would have this. -5 times 5 is -25 plus 3. So here I've got -22 is greater than -22. So that's when x equals 5. And these equal. So if that was a greater than or equals to sign, x equals 5 would be a solution. Most of you have said x greater than 5, which is good. Let's test 6. -7 -3 times 6 is greater than -5 times 6 plus 3. -7 -3 times 6 is -7 minus 18 is greater than -30 plus 3. I think this is going to be true. -7 minus 18 is -25, and that is greater than -30 plus 3, which is -27. Tick. Let's just do some steps of working here. So x greater than 5, looks like most of you have that solution. One person has x greater than 10. Any value greater than 10 will be correct, but there are values less than 10 that would also be correct. So let's just -3x greater than -5x plus 3. That's exactly what the question is, so good thing that is correct. Let's add 5x to both sides. Yeah, I'll solve that later. I want to get rid of the -7, so we'll add 7 to both sides. Yes, -3 plus 5 is 2. This is 10. Now I can divide both sides by 5. Sorry, by 2. X greater than 5. Now I'll just quickly show you what would happen if I did it the other way. Let's just start again with this. If I got rid of this and added 3x to both sides, that would give me -2x plus 3. Still correct. Get rid of the 3. Now I'm left with -10. So it's very similar to the line we had previously, which was 2x is greater than 10. Now I've got -10 is greater than -2x. If I divide both sides by -2, it's wrong because I didn't change the sign. We changed the sign. It's now correct. And this just simplifies to 5 is less than x. So x is greater than 5, 5 is less than x. They're equivalent statements. Both are correct. Both will get full marks. We just generally prefer to have the thing we're actually trying to solve on the left-hand side of the equation. It's just a convention. Nothing wrong either way. Show some responses. Good. Showing working there. Yeah, perfect. Okay, I know you looked last week at equations with fractions. So let's do some inequalities with fractions. There's no negatives involved here, so we don't need to worry about the sign changing. We have uncommon denominators here. So the first thing we'd probably want to do is rewrite this side with a common denominator. Is greater than or equal to 6. Looks correct. Yeah, if you really forgot how to do it and you just wanted to just stick random values in, I would be thinking, I want to pick a number that when I divide by 2 and 3 is going to give me a whole number. Wouldn't always work like that, but in this case it does. It's like, Vincent, you've got this correct. Well done. Lena, correct. Awesome. Great. So it looks like most of you are pretty comfortable dealing with algebraic fractions. So we need to combine these two terms. 3 and 2. I want to write with a common denominator, so we're going to multiply them together. Need to times this by 3 as well, and this by 2. Yeah. Let's just simplify everything now. That's 6, that's 6. Now I can write it over the common denominator. Gives me 5x on 6 greater than or equal to 5. Now all I need to do is get rid of the dividing by 6. So we times both sides by 6. Oh, that's nice and easy. I've got a 5 on both sides, so let's just get rid of them. Don't even need to evaluate that. And we get x is greater than or equal to 6. Let's test a number. Let's go 12. 12 on 2 plus 12 on 3. Well, that equals 6 plus 4, which is 10. And 10 is definitely greater than or equal to 5. So we know that's correct. All of you got that. Great. Well done. Next one. Okay, now we're going to look at graphing inequalities. I'm not going to explain this just yet. I just want to see how people go without any context. So here we have a number line. There's a point on the number line and an arrow going off to the left. So this is probably new for some of you. You would have seen equations, like solving equations on the number line, where you just draw, whoops, I'll keep on this, where you just draw a dot where the answer is. But here we have to show all of the solutions. So this arrow basically just means everything from this all the way down to minus infinity. X is less than 7. Yep. X greater than 7. Okay, so let's just show. Okay, so X is less than 7 is the correct answer. Let me just show some of the solutions. We have X is less than or equal to 7. This is incorrect. I'll explain why in a minute, but that's fine. You hadn't been taught this. I just wanted to see who would get it right from the start. X is greater than 7. You can see here, this is covering all of these numbers here. This is the way the arrow is going. It's a bit thicker. Sometimes, depending on the textbook or the resource you're looking at, they might draw it up here and draw the line above the number line. Our system just doesn't allow that to happen. So it's just a thicker line over the number line itself. Now, does anyone want to write into the chat why X minus 7, sorry, why X less than 7 is correct, but X less than or equal to 7 is incorrect? Does anyone know why? Yeah, good work. On Yinye, I believe. Sorry if that's pronounced wrong. The circle isn't shaded. So this circle here, you can see here, it's what's called an open circle or a hollow circle. That means that this point right here at X equals 7 is not part of our solution. If it was colored in, then it becomes part of our solution. So here we have X is less than 7. Okay. Like I said, if you got that wrong, don't worry, you hadn't been taught it. I was just interested to see how many of you already knew this. So that's really the two new things you need to learn for this topic. One is when we multiply or divide by -1, we have to change the sign. And the other thing is just on a number line, the difference between a closed circle here, you can see this one's shaded in, and an open circle, one that isn't shaded in. Okay, we've got mostly correct answers so far. So we're starting at -6, and -6 is included. So we can see here, -6 is definitely part of our answer. So we know X equals 6 is definitely part of our solution. But we can see here, 0 is also part of our solution. 10 is also part of our solution. So we want all of the numbers that are equal or greater than -6. Most of you got it correct. One person had it the wrong way around. That's fine. This is what we're here for. It's to learn. We're not being tested here. Just quickly, let's turn off annotations. Oh. Clear. There we go. So, clear off. So let's just see what the hint says. The plotted region ends at -6 or starts at -6. We can think of that either way. Filled circle indicates that -6 is part of the solution, and the inequality sign is either less than or equals or greater than or equals. That's the first thing. You check that this is solid, so you know it's one of these ones. The hollowed circle is less than or equal to. Now we can see that it covers all the numbers that are larger than -6, and -6 is included. So, oops. X is greater than or equal to -6. Now you can also, there's a different one now, X is greater than or equal to 5. You can use the symbols from here as well on the toolbar. X greater than or equal to 5. Yep. Okay. Now we know how to plot them. That's the same one. Why'd that get there twice? Let's move on. That's the same. What? Must have duplicated some slides and forgot to change them or delete them. Okay, so now you can draw on the screen and submit your answer. Plot the inequality X is less than or equal to 6 on the number line below. I think you can control the width of your pen when you're drawing these. But if you just want to use the thickest one, that's fine. Just make sure you clearly indicate whether you have a open or a closed circle at the main point. Bit different on Mathspace. You don't need to draw it. You can actually use the toolbars itself. So if I was doing it, we're at X less than or equal to 6. This is 5, that's 10. So this has to be 6 here. So whatever is happening, we want this point here, obviously. Let's go there. No. Let's put a point there. And we want to go that way. So we have X is equal to 6, and then everything where X is less than 6. Yeah, let me just show the responses. Most of you have something along those lines. Yeah. Yeah. Don't worry about how scribbly it is. It's very hard to get used to drawing on the screen. That's an interesting one. There's the main parts there though, that's fine. Let me clear my own drawing. Yeah, so it looks like you've all gotten that one, that's good. Let's go to the next one. Oh, we're running out of time, so I'm just going to very, very quickly go over this one. That's the same one, let's not go over it. That's good, less slides to go on. Whoa, hide responses, there we go. Okay, now this one we'll have to quickly solve it and then plot our answer. So draw anywhere on the slide. Feel free to include your answer in this part here and then draw your solution on the number line below. Main thing to be careful of here is this -8. First thing we want to do is divide both sides by -8. Great. Looks like Lena is on the right track here. Correctly switched the sign when she divided. That's a really nice answer from Lena there. Divided by -8, so this sign switches. 48 divided by -8 is -6. Close circle at -6, and all of the answers greater than that. Let's just test a number. If x is 10, I would have -80 is definitely less than 48. If x was 0, 0 is definitely less than 48. If I had -10, then I would have 80 is less than 48, which is wrong. And we know -6 is correct here. So well done. Let's just see what else we have. This one here looks like someone forgot to switch their signs around. Remember, if this minus is gone from here, this needs to switch directions. What else we've got? Okay, looks like most of you have that one correct now. That one's wrong, that's fine. Okay, next one, let's, oh, that's the same one. Oh, that's different. That's the one we just did. Let's just quickly do this one. There's a challenge question I want to get to at the very end here, which is just something a bit more interesting. Great. Lena racing to the solution here. Well done. Josh, looks like you forgot to switch your sign around there when you divided by the -8. And no one else has attempted this yet. Okay. Let's just move on. Really nice solution again here from Lena. Taking away 10 from both sides, dividing both sides by -8. We get x is greater than -2. Open circle at -2, off to the right. Let's test 0. 10 minus 0 is definitely less than 26. -5, that would make this -40. Oh, wait. What's happening here? Ah, yes. Yeah, if this is x was -5, we would have 10 minus -40 gives us 50. That's wrong. Okay, let's move on. This was the one I just put in at the end in case we were racing through it. Let's just skip that for now. Any questions quickly before we just quickly go and challenge, a couple of challenge questions? Doesn't look like it. Feel free to put in a question later on. Okay, Neville is saving up to buy a smartphone that is selling for $620. He has $440 in his bank account and expects a nice sum of money for his birthday next month. If the amount he is to receive for his birthday is represented by X, which of the following inequalities models a situation where he is able to afford the smartphone? Okay, Josh has just asked, I don't understand why you have to switch the inequality. The easiest way is really just to think about the really logical example. Something like 10 is greater than 5. If I have 10 on the number line here and 5 on the number line here, this is really saying 10 is further to the right than 5. On a number line, further to the right you are, the greater you are. But if I switched to -10, I need to switch the signs because -10 is all the way over here and minus 5 is here. Because we're sort of flipping the number line around, the sign itself needs to switch as well. So this is saying minus 10 is further to the left than minus 5. If something's multiplied or divided by minus 1, we're basically jumping from one side of 0 to the other. And so the sign, you can see here, 5 is less than 10, but minus 10 is less than minus 5. So it's basically like I was switching everything around. So if 10 is greater than 5, 5 is less than 10. Minus 10 is less than minus 5. So you can see here, pointing to that way, 5 is less than 10. I hope that answered it. It's really just because it has to be the case for the things to stay true. All right, x plus 440 is greater than 620, or greater than or equal to 620 seems to be the best answer. There's 440 in his bank, expects a nice amount of money. Yeah, so the phone he wants to buy is 620. He has 440. So x plus 440 has to at least equal 620 or be greater than it. We'll just quickly check that is the correct answer. Yes, great. Let's just move on from these ones. Okay, just very quickly, last 3 minutes. Quite a different question, but it involves inequalities. We have a bag containing 12 marbles. There are more red than green, but taking the green and blue together exceeds the number of reds. The total number of yellow and green marbles is more than the total number of red and blue. Find exactly how many of each color there are in the bag. Now, you could think about this logically, or we can actually set up some inequalities. Okay, just while you're thinking about this, I'm going to answer this question from Anine. How do you solve x is greater than 10 is less than 5? That's impossible to solve because 10 isn't less than 5, but let me just go to a more blanky screen I can draw on. If I had this, 5 is less than x is less than 10. This is known as a sandwich inequality because we have the two pieces on either side and x is sandwiched in the middle. So to plot that on a number line, you would draw an open circle, draw the line to 10, and have another open circle. If that was like this, 5 is less than x is less than or equal to 10, then we would just fill in this value here. So this is saying all of the numbers from 5, but not including 5, up to 10, including 5. I hope that answered your question, Anine. You'll be looking at things like this more so in year 11. It doesn't really come into year 10 just yet. Just one other thing I wanted to show you. If I wanted to solve something like 5x plus 1 is less than 10, I can actually solve this using a number plane as well. So I have this equation here, or this expression, 5x plus 1. We know that crosses here at 1 and has a gradient of 5. So we can draw that line, y equals 5x plus 1. And then we can also plot this line here, y equals 10, which is just a straight line passing through y equals 10. And then, so 5x plus 1, which is this line, is less than 10. So that would just be any of these values here. This is the line 5x plus 1. This is the line y equals 10. So any value to the left of this point here where they meet is a solution to our equation. I didn't pick very nice numbers. We'd actually get, if you're plotting this correctly, you'd have these values, but let's just quickly solve it. 5x is less than 10. No, sorry, 9. X is less than 9 on 5. So this point here is 9 on 5, and that would be our solution. Okay, I didn't actually give anyone room to answer this. Okay, let's just quickly explain the challenge question. I forgot to actually allow anyone to answer it. Let me just see in the chat if anyone has an answer. X plus 1, x plus 2. Okay, some of you might have to go, thank you. I meant to get to this quickly, but I think it was worth spending the time making sure we fully understood everything. Okay, so we have, there are more red than green. So R is greater than G, but taking the green and blue together, G plus B is greater than red. The total number of yellow plus green, Y plus G, is more than the total of red plus blue. So this is a system of inequalities. You won't need to learn how to do this in year 10. It's just a bit of a challenge question. That's the idea. So now I have these 3 inequalities and 4 variables. I know R is greater than G, which means, let's just look at this one. I take away B from both sides. I get G is greater than R minus B. This is a good challenge. I forgot to actually think about it myself and get an answer. Let me think. So there's a bunch of things to do here. Actually, we're going to run out of time to explain all of this properly, unfortunately. There are 3 different answers to this question. I'll let you know that. There is a link here. The solution is there. Otherwise, I recommend have a go at it during the week, and then first thing tomorrow morning, first thing next week, we can go over a solution for this. Unfortunately, I didn't leave enough time to fully go over this. Here's a starting point. We just basically want to write these equations, and then we know there are only 12 marbles in total. We can use that to help us figure out things. Obviously, if Y plus G is greater than R plus B, we know at least 7 of the marbles must be yellow and green. So that was 7 and that was 5. That's one thing we could then work out. R plus B is 5. R is greater than G. So R could be 4 or 3. G could be 3 or 2 in that case. But we'll go over this next week. Sorry, I didn't leave enough time for it. That's pretty much the end of this lesson today. I hope you all learned a few things about inequalities. Next week, let me just go back to the first slide. Next week, clear off. Next week, we'll be looking at interpreting linear relationships and probably look at some parallel and perpendicular lines and formulas for them and solving things like 5x plus 3 equals 7, using a similar method to the one I just showed you then. So thank you, everyone. Hope you had a good lesson. Enjoy school for the rest of the week and see you all next week.